Okay, so our mission today is to look at section 3.3. Just to back up with those Desmos activities, you should have finished your marble slides for today, right? If we have a chance, I'll look later. I think the last one was like make up your own crazy marble slide, and that's kind of fun. So I haven't looked at all of yours yet, but I will because I'm going to enter a completion grade for doing it. If you have questions on the marble slide and you're still stuck on it, I'm going to have you working on a Desmos activity today. So if you have a marble slide question, flag me down or flag Oren down, and you can ask us a question about that. But I want you to go to course docs and links. We are going to look at section 3.3. And there's two things we're going to do today. One is a Desmos activity. The other one is a worksheet that I'm going to hand out towards the end of class, a little matching activity. So I want you to go to the graphing stories. See that one under day one on 3.3? Graphing stories. And before you get started, let's see here. You can look at number 1. Graphing stories. Okay, I am going to try something here. Pacing. Oop. Okay, in number 1, the only thing you're doing on number 1 is you are watching a video. So go ahead and watch that video. Number 2 is where we're gonna spend most of our time here doing some work. Okay? So number 1, you got to watch the video, and then it says what different measurements are changing. What different measurements are changing? So type something in. I see a lot of you are putting height and time. Distance and time. Height, time, speed. These are all good things. Now, when you say time, I think we all understand that just time is time, right? The time of the video. But when we say height, we'd want to be a little bit more specific. Height of what? Somebody who wrote down height, what were you referring to? The guy? Be even more specific. The height of his head, of his foot, of his waist. It's all changing, right? But, for example, I could say the height of his arm, if he was waving his arm, and go like this, and the height of his arm would be changing, but the height of his head would not be, right? So be specific as to what you're actually measuring, because like the height of his waist is changing, but then when he slides down the slide, like his head and his feet, everything's moving at different times, right? So be specific. When you say speed, you probably mean speed of the guy, speed of his body, something like that. Distance, that's an interesting one. Who wrote distance? Distance of what?
Of where he's traveled.
So horizontal distance or vertical distance?
I would say horizontal.
Yeah, you see how there's a difference? Horizontal distance is like from here on the x-axis until here. But you could also call it vertical distance, which we would call height. Do you see what I mean by being specific about what we're looking at? Because what we're going to do over the next couple days is I'm going to give you like a description of something moving and a graph. And then you got to figure out what the graph is that goes with that movement, or what the movement is that goes with that graph, or what the verbal description of that graph would be. And it's extremely important. I'm going to look back at standard number 6 on the wall there. Attend to precision. It means be precise, be specific, don't be ambiguous. When you say height, height of what? When you say distance, distance of what? Be very specific on that. Okay, so what I'd like you to do now is The relationship we're interested in here, and I'm going to pace us. I want everybody to be on screen number 2. So is everybody on screen number 2? I just made you go to screen number 2. The relationship that we're interested in here is time is our x-axis, and distance above the ground is our... It's the height of his waist. Do you guys read the y-axis there? It says the height of his waist above the ground. That is the measurement that we are trying to measure. So what I want you to do is sketch a graph. And I see a couple of you have already done it. Now, you guys know that when you sketch a graph, you can either grab the marker and drag it, or you can grab the dot and just put some dots, and then play connect the dots. Remember doing that? Go ahead and work on that for a little bit. Because in step 3, they're going to show the answer. And I don't want anybody to look at step 3 until we're comfortable with step 2. That's why I'm locking you in at step 2. Whoa, that's not what I wanted to do. If I were doing this, I would probably plot a couple dots first, because you can push play and pause on the video wherever you want it to stop, right? I would plot some dots first, and then I would play connect the dots after that. I think that would help me be more precise if you do it that way, but I'm not saying you have to do it that way. As you're working on this, I'm going to pull up a couple examples for us to talk about. Oops. Okay, I'm going to pause you for a second. I want to look at the two that I put up here. These are two that I think just have slight flaws in them. So let's be picky. Let's try to be precise. This first one, the person who graphed this, and if this is yours, it's okay. What did that person kind of fail? What part of it are they not quite doing right? Yeah, right. Do you guys agree that he climbed up the steps and he got up there and he sat down and he just sat for a while? For like, I don't know, a couple seconds, right? So if you're going to sit there and not move for a couple seconds, what's going to be, what feature of the graph is this person? They kind of have it. There's kind of a flat spot there where where the guy's waist is not moving up or down. It's just stationary. But time is still moving, right? Like if he sits there for a while. So wouldn't we kind of have a flat spot for however many seconds that would be? That was the one feature from that graph that I thought maybe was missing. How about this graph here? Anybody want to critique that one?
Going down too fast.
Going down too fast? So does this slope right here, does that need to match the slope of the slide? No, it doesn't. Tell me why not.
Well, he picks up speed as he goes down, so it takes him less time to go down.
Yeah. Do you guys agree that on the way down he's sliding faster than he was climbing on the way up? Usually that's the case with a slide, unless you slide really slow and go really fast up the stairs, but that's not what he did, right? So this side should be steeper than this side, should it not? He was slower going up the stairs, faster going down the slide. It's one of the key misconceptions that students will make is they think that the graph they're making needs to be a picture of the slide. And it's going to be similar to the picture of a slide, but this slope does not need to model the slope of the slide because we're not measuring his height versus his horizontal distance. We're measuring his height versus his time, right? So don't let your brain think that you have to draw this exactly the same way that the slide is, because that's not what we're measuring, right? We're measuring time. And I know that's a difficult concept to think about sometimes. Okay, let's see where everybody's at here. Before we move on, I want to see everybody's sketch. Does anybody want some more time to finish their sketch? I got one of you that hasn't made one yet. Do we see some similarities in our sketches here? Okay, I'm going to unlock it now. So when you don't have to go to step 3 if you don't want to. You can finish your step 2 first. But when you get to step 3, they're going to show you the answer. So go ahead and keep moving on. Did you get yours drawn?
Yeah, I did it, but then I erased it because I didn't like it.
Gotcha. Okay. Notice when they show you the answer, it's very precise. Like every small movement of the guy's waist is detailed. So how did we do on our sliding man? Is anybody pretty confident? Did anybody draw a good graph? Or did you look at yours and say, whoa, I was way off? It's not easy. It takes a little bit of practice. So basically what's going to happen now, in step 3 and 4, or I'm sorry, we already did step 3. Step 4, step 5, step 6, and step 7. All are going to be different graphs. You got to do all 4 of them, and then the answers are step 8, 9, 10, and 11. So I don't want you to go to step 8, 9, 10, and 11 until you are confident with your 4, 5, 6, and 7, if that makes sense. So you can still work on yours and improve it unless you think it's good. Do you need a cable? Just make sure you give it back to me before you leave. Okay, I paused you for a second. Your graphs are looking good on the water one. I picked out two of them I wanted to talk about. What do we know how steep to do the slope when the water's going in, whether it's the slow or the fast? Do we know how steep to make it? Why not?
You don't know like
It's,
how much water is going in.
yeah, unless you're really good at the metric system and you can eyeball liters per second, that's kind of hard to do, right? So maybe you can. So because they are putting labels here like 1 liter, 2 liter, 3 liter, 4 liter, right? So if you can visualize liters per second, then yeah, you can kind of get the slope, but that's pretty hard to do. What's other than the fact that this one is steep, steeper, steep? So is this one, right? Steep, steeper, steep. What's the main difference between the two, other than the steepness?
Starting at 0.
Very good. One of them is showing that at time 0, the bowl is empty. The other one is showing that at time 0, it looks like there's just shy of 3 liters in the bowl when it started. So which one is it? Was it empty when the video started, or was there already water in there? There was water in the bowl already, correct? So I would say this person is being more precise than this person. They caught on to one little wrinkle of the graph that maybe this person didn't see. Do you see what I mean by really paying attention to detail here? Very good. I'll let you keep working here. I'll unpause you. If I know how to do that. There you go. On the egg one, I'm waiting for one person to show me the point that I'm going to make. Nobody's done it yet. I'll give you a hint. How many eggs do we start with in the egg one? 5. And there's 5 eggs for a certain amount of time. And then eventually there are 4 eggs, correct? So here's my question. Is there ever 4.5 eggs? No. Is there ever 4.2 eggs? No. Or 4.7 eggs? No. It goes from 5, and then it goes to 4. And then after 4, it goes to 3. Does it go to 3.5? No, because unless we actually break the egg in half and take half of it away, we're not dealing in half eggs. We're only dealing in whole eggs, right? So I don't know if that helps your graph or not. Okay. One of you got it. I'm going to give you credit, AJ. It was you. How is AJ's different than everybody else's? It's not a continuous curve, right? If you draw it like this, a lot of you were doing this. A lot of you did this, and then this, and then this, right? If you did it that way, what you're saying is, we had 5 eggs at this point, and then at this point we had, whatever time this is, we had 4.5, and at this point we had 4.2, and then finally we got to 4. See what? If you draw it with never picking up your pencil, you're gonna suggest to the viewer that there was 4.79 eggs at one point, right? Do you see how you got to take those chunks out? There wouldn't be any line here or here or here. It's what we call a step function. We're stepping from 5 to 4 and no number in between. So in order to graph it, you'd have to pick up your pencil. It's what we call a non-continuous function. We can't graph the whole thing by leaving our pencil on the paper the entire time. We have to pick it up and we have to make a jump with it. It'd be like if you're mailing an envelope and one stamp doesn't quite cut it. It's not enough postage and you only have stamps and you have to put 2 stamps on it, even though it probably only would have taken a little bit more than 1 stamp. Can you cut part of a stamp off and put it on an envelope and mail it? No. You got to use the whole stamp, right? It's either 1 stamp, 2 stamp, or 3 stamp. You can't do 1.5 stamps or 2.5 stamps when you mail a letter. Same thing here, right? Okay. I'll let you keep working. Good work. Pause you for 1 second. These are both very well done. I think one is just a little bit better than the other one. Which one do you think I like better? The left one? The right one? It's the right one. Tell me why I like the right one better than the left one.
He wasn't exactly at the camera when it started.
Very nice. This one is saying basically that he's touching the camera at time 0. And this one is saying he's at least a half meter away from the camera at time 0. This one's more accurate, right? He's not right up against the camera at time 0. Very nice, Bailey. Okay, let's get back to work. Once you get to 8, 9, 10, and 11, you're just watching the answers. Does it show you your graph on top of the answer when you watch it or not?
Yeah.
So you can see how yours compares? Show me what that looks like from your end. Oh, yeah. Very nice. Yeah, so you can really tell how accurate you were. If your graph is absolutely identical to the one that they're graphing as an answer, that would be really impressive. It should at least resemble it, though. It doesn't have to be right on it. Because you're making a lot of estimates here, using your eyeballs to estimate a liter or a meter.
Are 6 and 7 the same thing?
No. Read the axis. Distance from the camera, and then the other one is distance from the center of the merry-go-round. Same video, though, I think, right? When you get to number 12, they're just asking you to make up your own challenge. So you can pick any of the videos. Whether it's the egg video or the water video or whatever it is. But they're asking you to pick out two variables that are related to each other. It wouldn't even have to be time if you wouldn't want it to be. You could even mix two videos together. Amount of water versus how fast the guy is sliding down the slide. That would be very complicated. But you could do that if you wanted to. And if you get all the way to the end, I think it even lets you try other students' challenges. Is that correct? Which one of these two is more accurate for the distance away from the camera?
Second.
This one? Well, I think you guys all got to watch the answer. Which one's closer to the answer? It's this one, isn't it? What's wrong with this one? It's good, but what's wrong with it? Yeah, it's pointed. This would be like if he moved away and straight back, away and straight back. But that's not what happens. When something goes in a circle, like a merry-go-round or a Ferris wheel, it ends up being curved, right? And if you're familiar, if in high school, if you took a trigonometry course, it has like a sine or a cosine curve, right? So yeah, the circular motion is going to have that smooth curve as opposed to the sharp points like that. Okay, so you're going to have 2 things to finish for Wednesday. I'm giving you guys Monday off. I don't know if you knew that already. So don't come on Monday. But on Wednesday, I want you to finish the graphing stories, the one you're working on now, and most of you are pretty well done with it. Go ahead and make yourself a challenge for number 12. If you want to play and take the challenge of one of your teammates, go ahead, but you don't have to if you don't want to. Okay? Any questions on the Desmos that I want you to finish? The other thing I want you to do is this worksheet that I handed out. Everybody got one? What you're going to find is on the front page. Oh, I think maybe I shorted you guys one. Did you guys get one? I don't know.
No, you just got
I just didn't pass
Oh,
it
you,
down.
how many? I still shorted you
to
one.
do them all.
I couldn't count. Did you get one?
Yeah.
Oh, so I didn't short you guys one. Give me that back now. Sorry. Okay. Here's what I want you to do. There are 10 cards with 10 descriptions. Notice number 10 doesn't even have a description. Number 10 you have to make up on your own. So really there's 9 cards, right? There are 10 graphs, and I apologize, I stapled these 2 pages in the wrong order. I promise I do know my alphabet. But A, B, C, D, E, F, G, H, I, and J. There's 10 pictures of a graph, and there's 10 cards. I want you to match the description to the card. Okay? So you'll be able to do 9 of them, and when you do 9 of them, you'll have 1 graph left over. And then the graph that is left over, that goes with number 10. So number 10, you have to write in your own description, right? So all I'm going to ask you to hand in is the front page. So number 1, just in the space somewhere, write the letter of the graph that matches it. Just write it with your pen or pencil. Number 2, write the letter of the graph that matches it. So all you got to do is put your name on the front, hand in the front page, and then I'll give you a grade based on that. I made it worth 5 points, so each one is worth half a point. Shouldn't take you too long. I don't think it's as difficult as what you just did on the computer. So you got 2 things due on Wednesday. Have a good weekend. Stick around if you have marble slide questions or anything. I can help answer that. Otherwise, we'll see you on Wednesday.
Yeah, I was just on the marble slide. So
Yes.
I did that